Welcome back. So we're going to go ahead and continue working on solving systems by using the elimination method. So let's look at our example. It says 2x minus 4y equals 3 and negative 4x plus 8y equals negative 6. So the first thing we're supposed to do is stack the two equations right underneath one another. There you go. Second thing we need to do is we need to decide, should we eliminate the x terms or should we eliminate the y terms? Before we decide, we should probably analyze the numbers that we have to determine which one would be easier. How can I tell which ones are easier? Well, first, we always want to make sure we are manipulating the equation by the smallest number possible. Reason being is because we would prefer to work with smaller numbers versus large numbers. So, I'm going to have to analyze. I have a 2 and a negative 4 when I'm focusing on my x terms. I notice that there is a positive and a negative, so I'm not going to have to change the signs at all. They would cancel on their own. So now I just have to ask myself, what is the lowest common multiple of a 2 and a 4? The correct answer is 4, which means I would have to manipulate the entire first equation by multiplying by 2. Now let's go ahead and look at the y terms. So I noticed again there is a negative and a positive, so I'm not going to have to change the signs at all. Then I'm going to ask myself, what is the lowest common multiple between the 4 and the 8? And the correct answer would be 2, which means I would have to multiply this entire equation by 2. So notice I had a choice of multiplying by 2 or multiplying by 2. That seems a little suspicious, but I'm going to go ahead and try to get rid of the x terms by multiplying the entire top equation by 2. When I do that, please note that you do have to distribute 2 to every single term. The parentheses will tell you how far you need to go. So that first equation will change to 4x minus 8y equals 6. The second equation won't have to change at all, so I'm just going to copy it. Now here, I'm going to notice something. The positive 4x and the negative 4x will cancel each other out. The negative 8y and the positive 8y will also cancel each other out. But then here, a 6 and a negative 6 will also cancel each other out, leaving me with 0 equals 0. I know what some of you are thinking. You're thinking that either one, that there's no solution, or you're thinking that x and y equals 0. Be very careful. Please notice that in this statement right here, nothing says that x or y equals 0. In fact, there is no x, there is no y. Both of the variables were totally eliminated. Next thing. In order for something to be no solution, you were supposed to have a false statement. But if we look here, 0 does equal 0. So that's considered a true statement. If you recall, a true statement is going to lead to infinitely many solutions. So please do not be fooled by the zeros. If it is a true statement, the answer will always be infinitely many solutions. So let's take a quicker look on how to look at the systems. They are certain kinds of systems. When you notice that the variables get eliminated, you will have two choices to choose from. If it's a false statement, the answer will be no solution. So let me give you a couple examples. 3 equals 4 is a false statement. The answer would be no solution. 0 equals negative 2 is a false statement, which would lead to no solution. Then, what happens if you have a true statement? Well, then your answer will be infinitely many solutions. So let me give you a couple examples. 5 equals 5 is a true statement. The answer is infinitely many solutions. 0 equals 0 is a true statement, so the answer is infinitely many solutions. Please be very careful and don't be fooled by the zeros. Just remember that if it is a true statement, the answer will be infinitely many solutions. So let's go ahead and take a look at another example. It says solve using the elimination method. So step number 1, stack the two equations right on top of one another. Ooh, notice that this first equation is in standard form, so it's good to go, but this second equation is not in standard form. If you are not sure on how to change this equation into standard form, I suggest you refer to the second video and it will show you how to do that. So in this case, I'm going to keep the first equation the way that it is, and I'm going to change this equation to standard form. How will I do that? Well, I know that standard form requires me to have both variables on the same side. So I will have to move the positive 2x over to the left. How am I going to do that? Well, I need to go ahead and subtract 2x from both sides, leaving me with negative 2x plus 4y equals 8. Please notice that I put the negative 2y before the negative 2x before the 4y. If you're wondering why I did that, well, first of all, I wanted to make sure that the x's lined up underneath one another, and I wanted to make sure the y's lined up underneath one another. But also the reason is, in math, not only do we want to keep the variables before the constant, when we have more than two variables, we will put them in alphabetical order. Since x comes before y, x has to be first. Once I've done that, now I can go ahead and try to eliminate the variables. If I'm looking at my x terms, I'm going to notice that they're both negative, which means I'm going to have to change one of the signs. Second, I'm going to look at the coefficients. It's a 1 and a 2. So the lowest common multiple between a 1 and a 2 is 2, meaning I would have to change this first equation by a 2. Now let me look at my second option. If I am trying to eliminate my y's, I'm going to notice that I have a positive 2 and a positive 4, which means I'm going to have to change one of the signs. Here, then I'm going to look to see what is my lowest common multiple. I have a 2 and a 4. So my lowest common multiple is 4, which means I'm going to have to multiply this entire equation by 2. Notice again that I have a choice between 2 or 2. So in this case, it really doesn't matter. I'm going to show you the other way. I'm going to go ahead and try to eliminate the y's in this case. So I'm going to multiply by a negative 2. Notice we did say we had to change one of the signs, and that's why I chose a negative 2 versus a positive 2. I'm going to go ahead and distribute, and my new equation is 2x minus 4y equals negative 6. The second equation I'm just going to go ahead and copy because I didn't have to change it at all. Now I want you to notice something. The x's cancel each other out, the y's cancel each other out, so I'm left with 0 equals 2. If you're wondering how I got 2, I combined the negative 6 with the 8, which gave me 2. Now, I hope you notice that 0 does not equal 2. It will never equal 2. So this is a false statement. And if you recall from the earlier slide, we know that false statement leads to no solution. So the correct answer is no solution. So that concludes our video for today's lesson.